So it's now time to configure our Django application with Docker. Before we can configure Docker, we have to make sure that the Docker engine is installed together with Docker Compose. This can easily be done by going to this particular URL, docker.com/product/docker desktop. Then you install the Docker desktop version for your operating systems. For mine is Mac, but we also have it available for Windows and Linux. So install the Docker desktop for your operating system. Then the Docker desktop comes pre-bundled with Docker engine, Docker Compose, Kubernetes, among others. To check whether your Docker engine and Compose is installed correctly on your machine, you can run the following commands on the terminal. So go back to terminal and say docker -- version. You'll get your version, and then Docker Compose -- version. You'll get your version. So we shall start by creating a Docker file. So a Docker file is basically a text file that contains instructions, at times called commands or directives, which dictate how to create a Docker image. In short, Docker files are blueprints for creating images. In our root directory, where the manage.py file is located, we shall create a Docker directory. The Docker folder will hold configuration files, shell scripts, and associated Docker files for each environment. So in our root directory here, we're going to create a folder. This folder is going to be called Docker. Then in the same directory, create a new folder. We're going to call this local for our local development. Then since we're still in local development, create a new folder. We're going to call this Django, like that. So in that Django directory, we're going to create a Docker file. Kindly note that this file has no extension. So in the Django directory here, simple create a new file without an extension, just call it Docker file, like that. So let's start creating our Docker config. So we're going to use Python. Since in development we're using Python version 10, we're also going to use the from directory and select a base image. So our base image is Python 3.10. Whoa, 3.10.0. You are going to use the Slim Buster version. Then we're going to create the workdir. So the working directory instruction sets the working directory for any run, cmd, entry point, copy, and add instructions that follow it in the Docker file. So let's start first by creating an env directive. So you can say our application home directory is going to be /app. Then we're going to use the run command. So the directory we're going to make is app home. Then we're going to use the run directive again. So run directory, you can say in the home directory, we're going to create a static files directory for our static files. Then we're going to create a working directory. So the working directory there is going to be our app home, like that. Our home directory is on /app. So what you basically do here is create the directory, then also create in the home directory here, we're going to create another directory called static files. Then you're going to set this /app to be our working directory. So that is what that is all about. Then we're going to use the label instruction to set the metadata for our image. So we can say label here. So I can say maintainer. The maintainer here is just API-Imperfect at gmail.com. Then the other label is going to be for, so let me put the link to my YouTube channel. So YouTube is going to be, remember this is metadata, it's not very important, but it's useful. https youtube.com/c/API. API-Imperfect. Then we're going to add a description. So you can say label description. So the description here is going to be, let's say development image for real estate project. Good. Then we're going to set our environment variables. So the first one is going to be Python don't write bytecode. This basically prevents Python from writing .pyc files to disk. So you can say env. We're going to call it Python don't write, make sure the spelling is correct, bytecode. Set the value to 1. Then the next one we're going to set is Python unbuffered. So the Python unbuffered means that the Python output is transmitted directly to the terminal without being buffered, and that allows for displaying the application's output in real time. So you can say env. The next is going to be Python, then unbuffered. Make sure the spelling is correct. The value is 1. Then next, we're going to install dependencies. Please note you shall see me using the -y switch. So the -y switch basically ensures that the build does not stop and ask for a user prompt. So you're going to use the run directive. So you can say run apt get update. Then we can say and apt get install. Here basically installing all dependencies. -y, as I told you, ensures the build does not stop to ask for a user prompt. So the first one is build essentials. Then the next one is going to be psycopg2 dependencies to work with Postgres. So you can say apt get install -y. It's called lib pk like that -dev. The next one is going to be for translation dependencies. So you can say apt get install -y get text like that. Then the next one is going to be for Postgres dependencies. So you can say and apt get -y apt get install -y. We're going to use netcat gcc and PostgreSQL like that. Then we're going to clean up any unused file. So you can say and apt get purge -y auto remove -o apt semicolons auto remove double semicolons recommends important is equals to false. Then and we're going to remove recursively -rf /var /lib /apt /lists star like that. So in my typical fashion, we've definitely made some mistakes here. So this is supposed to be apt, then this is supposed to be important, not importantly, important like that. Then you save that. Then next we're going to upgrade our version of pip. So you can say, you can use this directive, run pip3. Then we're going to say install --upgrade, and we're upgrading pip like that. Then we're going to install requirements in this particular section, and we're going to ensure that they are cached. So you can say copy ./requirements.txt. We're going to copy this to requirements.txt or txt like that. But then we're going to make sure this is in our app home working directory, which is /app, then /requirements.txt. This is not correct like that. So we are copying /requirements.txt to /app /requirements.txt. Then we're going to install the requirements by using the run directive. You can say run pip3 install -r -r requirements.txt. So next we're going to run the entry point shell script. So we're going to create this shell script, then I'll explain it as we go. So let's go next. So we can say first we're going to run the copy directory from /docker local Django entry. We're going to have a file they call entry point, copy it to /entry point. So we're going to create this entry point file shortly. Then we're going to process the line endings of the shell scripts, thus converting any Windows line endings to Unix line endings. So how do you do that? You just run, then acd, then -i, then strings. So you can say S. We're going to use regular expressions here, / \r $g like that, entry point. Then we're going to make the entry point shell script executable. So how do you do that? You say run jmod like that +x on entry point like that. So here we're basically going to create this entry point file. Then we process the line in this place here. We're processing any line endings of the shell scripts and converting Windows line endings to Unix line endings. Then the last section here, we're just going to make the entry point shell scripts executable like that. We're going to start the shell script. So how do you do that? You can say copy from / same directory, docker local Django. There we're going to have another script. It's going to be the start script. Then we're basically going to run the same command there for the line endings, but this time it's on the start script. Then we're going to make it executable, but this time is on the start script. So the script there is going to be start like that, and you save it. Then lastly, we're going to have the directive for the entry point. So you can say entry point here. So for the entry point here, our executable here, remember, is going to be on, our executable there is going to be on / entry point like that. So let's create the entry point file we mentioned in the Docker file. It shall be created in the same Docker local Django directory at the same level as the Docker file. Kindly note that the entry point file also has no extension. It's just entry point. The purpose of the shell script we shall declare in the entry point file is to ensure that you get connected to our database service before we spin up our API service or any of our services in our container. These services shall be declared shortly in the Docker compose file. So here, in the Django directory, create a new file. We'll create a new file here. This is just going to be entry point like that. Then here we're going to now create the script. So we can say bin bash like that. Then we're going to say set-o error exit. This basically means that if any of the commands in your code fails for any reason, the entire shell script fails. Then the next one is going to be set-o pipe fail. This basically means that fail exit if one of your pipe command fails. Then the next one is going to be set-o noun set. So this basically means that this will exist if any of your variables is not set. Then we're going to declare Postgres. So you're going to say Postgres_ready. So you can say for Postgres ready, you can say Python, then say and. Please make sure the syntax is just as it is here. So let's have that there. Then you can say we're going to import sys like that. Then you're going to import scopg2. Then you're going to have a try block. So you're going to say try. So you're going to say scopg2. We're going to try to connect to our database. So you can say connect. And our DB name, our database name is going to be $. It's Postgres. Let's see. It's here. It will say it is Postgres DB. Copy that. Bring it there. Then we're going to say our user is going to be Postgres user like that. Let's confirm Postgres. Yes, Postgres user. Then next, we're going to say the password is going to be Postgres password. Confirm from env file. Postgres password. Good. Then the host is going to be the Postgres host. Confirm. Not Postgres host, it's PG host. Then the port is going to be PG port like that. Confirm here, PG port. Good. Then after this, we're going to have the except block. So you can say except scopg2 dot. In case there's any operational error, if there's any operational error, we're going to exit from the system. So you can say sys.exit with an exit code of -1. Then we can just say sys.exit if everything is okay. Then there we are going to say and. That's basically it for that. Then we can say and have another statement here. You can say until Postgres ready, we're going to do something. So you can say do echo. We're going to echo something to the console. Whoa, not backticks. We're just going to say this is &2. Let's say echo. We're going to say echo here, waiting for Postgres SQL to become available. You can do a sad face, whatever you want. Then you can say sleep. Then done. Oh, not backticks, done. Then we can have another echo statement. Just copy that, put it there, and here you can say echo PostgreSQL is ready, like that. Then you can have a smiley face this time round if you wish. Then we're going to execute this. So you can say exec, then $@ save this. Then I even think here where we're saying postgres.connect, let's have all this in double quotes. So let me just make all this be double quotation marks. So next, let's create our start script. This script ensures that our models are migrated and the Django server is run. This file should also be created at the same level as Docker file. So here, create a new file here. I'm going to call this the start script. So here again, let's just copy this here. Whoa. Then we're going to copy the same things, error exit, pipe fail, and nonset. I'd explained this before. Then save that. Then we're going to say for the start script, we're going to run Python 3 manage.py migrate -- no input. Then we're going to also run Python 3 manage.py collect static, no input required from the user. Then Python 3 manage.py we're going to run server on port 8000, so 0.0.0.123.0.0 on port 8000, like that. Then you save that file. Then we're going to add a .docker-ignore file in the project root. So docker-ignore basically allows you to mention a list of files or directories which you might want to ignore while building the image. So in our project root here, where manage.py is located, create a new file here. We're going to call this docker-ignore. So no, wow, this is going to be called .docker-ignore, like that. Then I basically have a snippet for this, so you can say .ignore. You can copy this from the repo, save the docker-ignore file. Lastly, we're going to define a Docker Compose file in the root of our project. So Docker Compose is a tool for defining and running multi-container Docker applications. It uses YAML files to configure the application services. It also performs the creation and setup processes for all the containers with a single command. So in our root directory here, we're going to create a new file. We're going to call this dockercompose.yml, like that. So now it's time to declare our services. So we're going to use the version of Compose. The version is 3.9. We're going to declare the services that make up our application. So you can say the services that declare our application. One is going to be called the API service. So our first service is the API service. So for this API service, we're going to build it. And we're going to build this service using a context. And the context is the current directory. Remember, Docker Compose is in our root directory. So we're going to use the files in the current directory to build our API service. Then we're going to specify the Docker file. So the Docker file to be used for building this service is in ./docker/local/Django/Dockerfile, like that. So remember, Docker local Django here. We're referencing this particular Docker file. We're going to set up a command. So the command here is going to be the start script. So you can say start. So what we're basically saying here, look into this directory Docker local Django and look at this script here, the start script, which basically, as we said here, is going to migrate, collect static, and run the server. Then we're going to declare some volumes, like that. So volumes here, we're going to say the first one is make sure syntax is correct, /up. So the volume is used to map files and folders on the host to the container, so that if we change the code in the host, the code in the Docker container will also be changed. So this is very useful, especially in development. The next one is going to be for our static files. So you can say our static underscore volume. This is going to be in /up/static files, one that's in our root directory. Let's just confirm something here. In our real estate settings base.py static files. Yes, in the base directory static files. Okay, that's correct. Then for media files, we're going to create a media volume. So media volume is going to be /app/media files, like that. Then we're going to do a port mapping. So you can say for ports, we're going to map port 8000 to 8000, 8000 the container to 8000 on our machine. Then we're going to specify our environment files. So you can say our project has an environment file, and that environment file is located at the root directory .env, like that. Then we're going to say that this API service requires a Postgres database, so it depends on, so you can say depends on Postgres. Our service, are going to call it Postgres-DB. You can call this any name you want. Then you can say networks. So our services are going to be networked. So you can say networks here. So the network is going to be called, let's call this estate-react. So you can call the network anything you want. Save that. Then next, let's now declare our service, the PostgresDB. We said our API service depends on the PostgresDB service. So make sure when you're declaring the services, they're the same level. So it should be here. API and Postgres should be at the same level, like that. So you can say our service is called PostgresDB. Let me confirm it's at the same level as API. Good. Then we can say image. Image we're going to use is, let's say, we're going to use Postgres version 12.0. We're going to use the Alpine version. Alpine is just basically the lightest version. Then we're going to say the ports. We're going to do port mapping. So the ports here, the ports here is going to be, we're going to map the default port, which is 5432 to 5432. Then we're going to declare volumes. So volumes here in our Postgres database service is slightly different. So volumes here is for persistent storage. Where do you want to store our data? So by default, it's stored in Postgres. Postgres underscore, so you can say Postgres underscore data. We're going to store it in the default location, which is on /var/lib/PostgreSQL, like that, /data/ then Postgres database, remember, has some environment variables, so you can just say our environment here. We're going to say Postgres user is Postgres user, basically these things here, the Postgres user, password, and database. So let me just copy this here, like that, bring it to Docker Compose and say this is wrong, tab that in, then tab that in, like that, hyphen. So create hyphens for all of them, like that. Then so you say Postgres user is going to be, we're going to use an environment variable, so you say use a $, and it's going to be copy this Postgres user, the same to this $, Postgres password, the same to this, it's going to be $, then PostgresDB, like that. Then we're going to declare the networks, so you can say networks here is just going to be estate-react. Remember, you can call this network whatever you want, like that. Then remember we had mentioned networks, so now we can say here, so always make sure your indentation is correct. So you can say here networks, so it's at this far edge, it's at the same level as services. So you can say the networks here is going to be called, we called it estate-react, estate-react, like that. And we're going to use the default bridge, so you can say driver is going to be bridge, like that. Then also volumes, so we're going to declare our services volume, so you can say volumes here. The first one is Postgres underscore data, and that volume was declared somewhere here. Then the next ones are static. There was a static underscore volume, and media underscore volume, like that. So remember, these ones were up here in the API service. You have static volume and media volume. Yeah, and that's basically it. So just be careful that when you're declaring your Docker Compose file, make sure the indentation is correct. Otherwise, you're going to have problems of your lifetime. Then lastly, we're going to amend our .env file, specifically the PG host setting, this time to point to a Postgres database service. So remember we were developing this application locally using our local installation of Postgres, but this time we want to use Docker containers. So this host can now not be localhost. This one has to be the name of our service. The name of our service is Postgres-DB, like that. So if you come to Docker Compose here, our service is PostgresDB. Let me just copy this to make sure I didn't make errors, as I always do. So host is PostgresDB, like that. And to stop my local installation of Postgres, I'm using an app called it's called Postgres app. So I can stop my local installation of Postgres there, so that the port 5432 is left available. Or we're going to amend our main urls.py file to remove the media URL setting, since we shall be serving our static and media files using NGINX. So we go back to real estate here. Settings, we have URLs. So basically we're going to remove this. We're no longer serving things locally. We're going to use our Docker containers and NGINX. Save that. Then we're going to run the Docker Compose. So remember, we have declared some environment variables in our Docker Compose OML file. To see how the Docker Compose file content looks after the environment variables have been substituted, we can run in our terminal Docker Compose config. Here we can say, clear this, you can say Docker Compose config, like that. So as you can basically see for Postgres service, remember, here we just want to confirm if these things were loaded correctly, these environment variables from our .env file. As you can see, estate is loaded, admin 123456, and the user is properly loaded. The same applies for environment here for the API service. You'll see all our environment variables are being loaded. So we've set up our Docker Compose file correctly. Next, we're going to build our containers. So in the terminal here, let's just clear this. We're going to say Docker Compose app --build detached mode -d. Then we're going to remove any orphan containers that exist. Run that. Please be aware that the first build you run may take some time, as packages need to be downloaded. The time taken also depends on your internet connection speed and your machine specs. Okay. Yet another beautiful error. So the beautiful error was as a result of how we had set up this particular line in our Docker file. To avoid such errors, just go to project repo and just copy my command and all shall be good. So you can go back to the terminal here and say Docker Compose app build. This time let's hope there are no errors. Let's build this. Good. You can see that our containers are built. So please be aware, as I said before, the first build you run may take some time as packages need to be downloaded. The time taken will also depend on your internet connection speed and your machine specifications. So once your containers are built, run the logs to see if there are any issues. So you can say Docker Compose logs, like that. Then as you can see, our server has started. Okay, let's just start from the very top. So here we can see that our script worked. Our Postgres database is ready. You see here it was waiting for Postgres to become available. Then now Postgres was ready. Once our database service was ready, is when the start script went and applied the migrations. After applying migrations, it went and ran the collect static command, then ran our server. So it basically did this in this order: migrate, collect, and run server, but only after making sure that our database service is ready. Good. So our server seems to be running, and you can see there are no error messages. Our logs are okay. Then let's bring down our containers. To bring down your containers, just clear the terminal. You run Docker Compose down. And remember, especially for your Postgres database service to run, you have to make sure that if you have any local installations of Postgres, make sure that you stop that service or you change the port, because we put our service to also run on port 5432. There'll be a clash. So either you stop your local installation service or you change the port that your Postgres database container or service runs at. So I think that's a good point to stop this. So as usual, let's commit our code. Go to a Git client and say here, this is setup. What did you do? Set up Docker with compose, like that. Then as usual, you're free to push this to your GitHub repo. So that marks the end of this video. See you in the next one. Cheers. To shorten the Docker commands that we type out in the terminal, we shall use the make utility. The make utility requires a file, that is, a makefile, which defines a set of tasks to be executed. Please note, it's not a must for you to use makefiles. You could as well type out all the Docker commands on the terminal, as you have seen us do before when building our containers. So in our root directory, create a makefile. So here, create a new file here, call this makefile. Then we're going to declare our tasks in the makefile. But first, we have to declare an if block where we can load in our .env file. So you can say if nec, that's a syntax, then and if. Then here we can say we're going to, that's a comma, we're going to use some regular expressions. We're going to set in our wildcard. So the wildcard, we're going to say to ./.env, like that. Then we're going to say include .env, then export. So what we're going to export, we're going to have an environment. So env file parameter. So that parameter is going to be the environment file, and that environment file is .env, like that. Save it. Then now we're going to declare our tasks. So let's say the first task is going to be build. So for the build command here, so remember when you're creating the task, you have to tab it out. Don't add spaces, just do one tab like that. So the command we want to run, let's say it's called docker compose. You've seen this command before. Docker compose up --build -d, meaning run in detached mode, then remove any orphans, like that. So that's going to be the first task. Then the next one is going to be up. So again, remember you tab, then you can say docker compose up. The next task is going to be down, to bring down our containers. So you can say this is docker compose down. Next task is going to be show logs, like that. Then you can say tab that in, it's docker compose logs. Then the next one is going to be for migrating our database, even though we have a shell script for this. So let's just say docker compose. So here we're going to execute on our API service. On API service, we're going to run Python 3 manage.py migrate, like that. So you're running the Django migrate command within the container. So the next one is going to be make migrations, like that. We're going to say docker compose. We're going to execute on the same API service. Remember, I hope you know what I'm talking about. Remember our service here, we called it API. So if you call this service maybe test or whatever name, that's the name that you add here. So the service, we're going to run Python 3 manage.py. We're going to run make migrations. Then the next one is going to be to create a super user. So you're going to say that's docker compose execute on the API service Python 3 manage.py, create super user. It's create super user, like that. Then the next one is going to be collect static, docker compose, like that. We're going to execute on the API service. We're going to run Python 3 manage.py collect static, but this time we're going to add the flag of no input. We don't want any input to be added. Then the next task is going to be down -v. So no, down, let's say call this down -v, like that. Make sure you tab that in. Then this one is this task is going to help us to bring down our containers and remove any associated volumes. So remember, This down command here just brings down the container, but this one now brings down the container and removes all the volumes. So you can tab that in and say docker compose down with a dash v flag, remove everything plus the volumes. So remember, actually, all these names here are built down, like you can name these things whatever you want. Actually, the tasks name, you can name this thing whatever you want. These are just the names I've chosen for this particular project. Then maybe volume. Whoa, volume here. Here we can run docker volume inspect. Then we are on estate src. That's our root directory. And the volume we created was called for our database was postgres underscore data. You just get that from here. This volume. So I want basically this command. If I say make volume, this command is going to inspect my Postgres volume. So that's what I'm creating here. And the volume is going to be created in our root directory underscore the name of the volume. And the name of the volume is here. Here. In our service, Postgres database, the volume was Postgres underscore data. Then the next one, I want to run one for my database. So my database, I can just call this estate db. So here I can run, we tab, you can say docker compose. We're going to execute on the Postgres database service, Postgres database service, Postgres DB. We're going to run PySQL. Our username was admin, and the database name was estate, like that. So here we want to run the PySQL terminal command on our database to inspect the Postgres database. Then we can run one for test. So if we want to test our app, we can say here we're going to use PyTest. So you can say docker compose execute on the API service. You're going to run PyTest like that -p. We don't want any warnings, so you say no warnings like that, and using the coverage. Then next we're going to run the HTML version of PyTest to generate a HTML report. So you can say test, so you're going to call this HTML. So here you can run docker compose execute on the API service PyTest -p, no warnings again with coverage, but this time also do the coverage report as HTML. So the coverage report as HTML like that. Here the first one will just get the coverage report in the terminal, then here the terminal and also the HTML version. Then to run Flick 8, we can just call this task Flick 8 like that. Then you can say, make sure you tab again, docker compose execute on the API service, run Flick 8 in the current directory like that. Then the next one is going to be for black. So you can say black check. So we're going to use this task we're going to use black here to check for any formatting issues. So you can tap that in and say docker compose execute on the API service. We're going to run black and we want to check, and then we want to exclude. We're going to exclude any migration files. So I'm not going to check the migration files. Migrations like that, the current directory. Then the next one can be black diff. So this one I'm going to use black to check the difference after formatting is done. So you're going to see all this. We're going to do all this practically. So docker compose execute on the API service. You're going to run black diff. Then you're going to exclude. We're going to exclude migrations, the current directory. Then we're going to run now black itself. So here we're going to run black to actually format our code. Okay, you can run a check, then they do the difference, then actually format the code. So you can say docker compose. We're going to execute on the API service black now. Then we're going to exclude and then we're going to exclude migrations as usual. Then next we're also going to run one for isort. Remember we had installed this before, so you can say isort check. Let's just call this isort check like that. Here we can run docker compose. Docker compose, execute on the API service isort like that. In the current directory, check only is true. Then we're going to skip checking the env, our virtual environment, and we're also going to skip migrations, the migrations folder. Then you can say isort diff. Here we're going to run docker compose. We're going to execute on the API service isort. In the current directory, here we're going to run diff. Then we're going to skip our virtual environment. Then we're going to skip again migrations. Then we're going to run isort itself. So we can say, type that in, docker compose. We're going to execute on the API service isort. The current directory, we're going to skip our virtual environment. Then we're going to skip any migrations. Yep, and I think that's basically it. So as you can see, by us creating these tasks, we're going to avoid having to type all this docker compose blah 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 in the terminal. So just say like make volume, make state db. If you want to test, just say make test rather than typing all these docker commands in the terminal. But if you don't want to use Makefiles, please, you're free to just, instead of using the tasks that you're going to use, please feel free to just type out all these commands. It's just that I don't like typing all these things in the terminal. It just takes too much time and it's kind of annoying. So save this file. So in our typical fashion, we've definitely forgotten something. So let's go back here in our app docker command. I want to run it in detached mode. So just add -d like that. Then save the Makefile. So this time we're going to build the containers with the make task. So in the terminal, now instead of running like docker compose app build -d remove orphans blah blah blah, go back to the terminal and just say make build. As you can see, it's running the same command. Good. As you can see, it's done. So we can confirm that the Postgres database persistent storage we declared with the volume flag was created. So how do you do this? Remember, we just say make volume. So as you can see, if you get this response, it was successfully created. As you can see, it's created under shsrc postgres _data, then data. So if you get a response like this, you are good to go. Lastly, we can create our super user. So first, let's just see if there are any errors. So you can say make show logs. As you can see, we have no issues. Our server is running. Postgres is ready, our migrations are applied, static files, blah, 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 and our server is running. So clear that. So now let's create a super user in our container. So what was the task again for super user? Here, make super user. So you can just say make super user like that. So we can pass in the email address. They say api.imperfect@gmail.com. Then the username, let's just make it Alpha or Gilo. Remember, this time we're now creating the super user in our Postgres database that is running in our container. That's why we have to recreate this. So first name is Alpha, last name is Ogilo, then password can be admin123456, then admin123456. Good. So that is done. Then we can log into the admin at localhost 8000 super secret. So let's go back to our here. Let's go to the localhost 8000. Of course, we have to go to our admin, which is in super secret. Then log in, give it a while because this time it's running from our container. Yep, now we are good. As you can see, now the profile for the admin was created. Then also here, good. We are now good to go. Lastly, if you want to connect to your Postgres database instance and confirm that the database was created, we could also check this in the terminal. So we can come to the terminal here and say make to check our database. What did we say? We called it AstateDB. So you can say make AstateDB like that. As you can see, it launches PySQL in our Postgres instance. So to list the database, you can just say /list. As you can see, our estate database instance was created. Then what else can we do? We can connect to the database. So we can just say connect. As you can see, you're now connected to the database estate as a user admin. Then to list the relations in the database, you can say /dt. Is it backslash? I think that's /dt. Then you can see all our relations here, user, properties, and all the rest. Then to quit PySQL, you can just do /q, and that is it. So remember, this is that's a way of accessing a database without using a tool such as pgadmin when you're using your Postgres instance in a container. Since all is well, we can commit our code. So go back to the Git client here, and let's say here this was a cho, and here was setup, make, file, tasks like that. Make the commit, and as usual, feel free to push it to GitHub. So it's time to confirm and correct any code quality issues we have as of now with the help of Flake 8, Black, and isort. Remember them? We had installed them in our virtual environment a long while ago. So first, we're going to create a file in our root directory. So go back to your project. So the file is going to be called pyproject.toml. So pip518 defines a pyproject.toml file as a configuration file to store build system requirements for Python projects. So by default, Black looks for a pyproject.toml file starting from the common base directory of all files and directories passed on the command line. If it's not there, it looks in parent directories. So in the root directory here, create a new file. We're going to call this pyproject.toml, T-O-M-L file like that. Then here we're going to specify that the tool we're going to be using is Black. Then we're going to extend, we're going to exclude in virtual environment. So we can say like that, triple quotes. Then we can say / open curly braces, then enter. Then here we can use a pipe character, we can say exclude.env like that. Then at the bottom here, make sure you close that. Then at the bottom, close the quotation marks like that. So with that done, you can bring down your containers, then build them up again. So you can say make down, then rebuild them again. So you can say make build. Good. With our containers built, so first we're going to run Black and sort out any issues before moving on to isort and then Flake. So you can say make Black check like that. Let's see what it's saying. It would reformat the real estate ASCII file. Okay. So we can do, to confirm what it's going to do, we can now say make Black and then let's say diff. What basically this does, it looks at this file that it wants to reformat and gives us what the difference will be. So what's going to happen here is basically we're going to remove this file here and then add this file. So, okay, not this file, this line. So what the basic difference here is it's just going to remove the single quotation marks and replace it with the double quotation marks. So there's going to be a subtraction in the ASCII file and addition. That's what this is all about. So I think I'm happy with this because all it's going to do is just add double quotation marks to this line. So if I'm contented, you can now say make Black like that. And as you can see, it would have reformatted now that file. So if you go back to ASCII, real estate ASCII.py file, that line that I was talking about has been reformatted. So you can do that and make those changes. Then the next one you're going to do is for isort. So you can say make isort check. Whoa, check. So you can see all these files are incorrectly sorted. So if you want to check the difference, as usual, you can say make isort, then do the diff. So it's going to show you like in each app what it's going to remove and what it's going to add. So for example, in the models here, so this means before, then positive means after. So here it's going to remove this line from that and sort it out and put it at the bottom here. The same for this folder, views.py file here, and the same for the add-on. So I think I am okay with that. So I can now run isort. I can say make isort to now sort it out. Good. And I skipped and formatted all those files. Nice. So the last thing we're going to run is Flake. So the only difference between Black and isort is, you see, most of the things are done automatically for us. But with Flake 8, the linting issues displayed in the terminal need to be fixed manually by going into those files and making the changes suggested. We can clear the terminal, run make Flake 8. Aha. So as you can see here, we're talking about like files that may be undefined. So what you need to do for Flake 8, you have to go into all these files and make the settings. So as you can see here in settings.base, they told in line 148, module level import is not at the top of the file. So let's go and check even one of them and see. So real estate settings base, number 148. Yeah, you see this. So what you can come and do is like cut that, bring it to the top of the file as it's suggesting, and save it. So you can also go and do all these changes in all these files. I'm not going to go through all this on this video to make this video necessarily long, but please go into all these files and make the necessary corrections. So with that done, I think it's time to commit our code. So you can go back to your Git client here and say, here we basically, this is basically a chore. Here we fix code quality issues, make the commit. Next, we're going to have an intro to Django testing. So to test Django apps, you can either use PyTest or Django's built-in text execution framework. We shall be introducing PyTest in this tutorial. Kindly note that we shall not write all possible tests to cover all the apps we have so far. This is just an introduction. There are two paradigms when it comes to testing. In organizations that adhere to strict agile principles, they enforce test-driven development, which entails step 1, we write a test. Step 2, run the test, ensure it fails. Step 3, write just enough code to get the test to pass. Then step 4, refactor if necessary. In other scenarios, we write tests after building the feature. You should always remember to test all aspects of your own code, but not any libraries or functionality provided as part of Python or Django. In this tutorial, we shall write tests after building the feature. This makes it easier to understand testing in Python and Django, especially if you're new to testing. So first step is going to be bringing down our containers if they are running. So you can just say make down like that, bring down the containers. Then we're going to set up PyTest. So open the requirements.txt file and we're going to add PyTest Django, PyTest Factory Boy and Faker to the file. So go to requirements.txt file here. Here we're going to add PyTest Django. We're going to use version 4.4.0. So PyTest Django is a plugin for PyTest that provides a set of useful tools for testing Django applications and projects. Then we're going to add PyTest Factory Boy. We're going to add version 2.1.0. So PyTest Factory Boy makes it easy to combine the factory approach to the test setup. Then we're going to use Faker. So Faker, we're going to use version 8.9.1. So Faker is a Python package that generates fake data for you. Save that file. So for our tutorial, we're going to keep our tests in a single test directory in the root of the project. So in the root of the project here, create a new folder. We're going to call this tests like that. Then let's make this a Python package, create a new file. It's __init __.py. Then we're going, for now, let's test users and profiles. So create a new folder here. We're going to create this users, then another one here, profiles, then create a new file here, _init __.py. The same applies for profiles, create a new file, _init __.py, like that. So we have tests init, then users init, oh, just a minute, yeah, users init, then profiles init, like that. So by default, PyTest will auto-discover test files that start or end with the word test. Test functions must also begin with test underscore, and if you want to use classes, they must also begin with the word test. So next, we're going to add a pytest.ini file in the root directory. This init file points PyTest to the Django settings and Python files where our tests shall live. So in the root directory here, let's just close all this. That's where the manage.py file is. Here we're going to create a new file. It's called pytest.ini, like that. Then we're going to make some configuration. We're going to say this is pytest. Then the Django settings module. So the Django settings module is going to be it's in real estate dot settings dot development. Then the Python files, we want to test our tests.py. Look for any file that starts with tests underscore star.py, or any files that start with something then underscore tests.py. So those are the Python files PyTest should look out for. So we're going to set up coverage. So before writing tests, we need a measure of how much code is executed during testing. Here is where code coverage comes in. By adding code coverage to your test suite, you can find areas of your code not covered by test. Since we're using PyTest, we'll integrate coverage.py with PyTest using PyTest curve. So go back to requirements.txt file here, add PyTest curve, like that, version 2.12.1, save that. Then in our root directory, let's configure coverage in the previously created setup.cfg file. We're going to add the following config to exclude a number of files from the coverage results and enable branch coverage measurement. So let's go back to setup.cfg. We had created this file like a long while ago. So here, just after Flake, we're going to set up coverage. So you can say coverage run. So here the source is the current root directory. So it's just dot, like that. Then we're going to put the files to omit. Whoa. So omit. So we're going to omit any apps.py, settings, URLs, wizgy, manage, base, development, etc. So let me just add them. You don't have to watch me type this. So we're omitting any apps.py, settings, URLs, wizgy, manage, contest, base, development, production, migrations, any tests, env, and virtual environment. Then at the end, we're also going to set up a coverage report. So you can see for coverage report, like that. We want to show any missing files. So show any missing tests, looks are true. So here we're going to show any lines that are missing tests. Next, we're going to update the containers. We need to rebuild the Docker containers since the requirements are installed in our containers at build time rather than runtime. So whenever you add any requirements to a requirements.txt file, you have to rebuild your containers because that's when the requirements are installed in our containers. So go back here, you can say now make build, let that run for a while. Good, with our containers up and running, let's check if there are any issues. You can say make show logs. Aha, things seem to be running well. So what you can do now here is we can now run coverage both in the terminal and also generate a HTML report. So to view the test coverage in the terminal, you can say make test, like that. Okay, this is beautiful. Aha, okay. So setup.cfg. So what basically happened is we built our containers. You see here we didn't save our file. Wow. So just save this file here. Then let's just clear this. Let's run make build again just to be sure. Good. So now we can go and run make test. Nice. So as you can see, we get our test results. We are seeing no tests run because we don't have any tests yet. And you can see our coverage report for all the apps that require testing. That's the beauty of coverage. So I personally don't like this terminal version because it's hard to decipher stuff and know what to test. So what we can do is generate a HTML report of it. So you can say make test HTML. I hope you remember how we got this, because if you come to the Makefile here, we created our task for it here, make test HTML. So we're going to use it. Good. So the coverage HTML is written to HTML coverage. So if you go back to your IDE, you'll see there's a folder here called HTML coverage. So what you basically need to do is run this index.html file. So since I'm using live server, I can say go live. Then I can open, the server started on localhost 5500. So I can just go back to my browser to say localhost 5500, HTML curve. Then you can see the report. So as you can see, our coverage report is 34%. So it's basically the same report that we got here in the terminal, the same thing. But now the beauty about this is, like, for example, if you want to test, we want to test like users and profiles. So if you go to apps users, where are you? So let's say managers here. If you click on each particular file, it will show you like the lines that are missing tests. And that's why we put here, somewhere here, we had said show missing true. So at least the HTML version of this report makes it easier for us to like know what to write tests. So managers, go to models. These are the lines that require testing. Go to any app, let's say inquiries, views, you'll see all those require testing. So as you can see from the coverage results, our current test coverage percentage is low. It's at 34%. So we're going to write the tests in the next section. So for now, we can commit this. We can come to Git client and say, this is a char. Basically, we are to configure PyTest and coverage like that. Then make the commit. So first, we're going to test the user model. So in the test directory, create a file called factories.py. So this file should be at the same level as the init file. So in the test directory here, new file, whoa. Okay, new file here. This is called factories.py, like that. So basically this file is where we shall declare our model factories. So factories are Python classes that behave similarly to Django models. They write to a database as Django models do and allow for a lot of automation. When declaring our factories, we shall use lazy attributes. So fields with lazy attributes are fields whose attribute values are computed and assigned after computation from other elements. Such fields also need values assigned each time an instance is generated. So in a test factories.py file here, you can say import factory. Then from apps.profiles.models, we're going to import profile. Then from django.db.models.signals, we're going to import post save. Then from Packer, we're going to import factory as Packer factory, like that. Then from real_estate .settings.base, we're going to import the auth user model. Then we can have an instance of Faker. So Faker is going to be Faker factory .create, like that. Okay, the reason we are getting this import is because it's not installed in our local virtual environment. So we can, it's not a must because we're going to use our containers, but let's just do it. So you can say just pip3 install requirements.txt. Good, and those squiggly lines should go away. So now we're going to create a profile factory. So you can use this decorator. It's called factory.django.mute signals. Here we're going to mute the post save signal, because remember when you create a user, the profile is, there's a signal sent to create the profile. So we want to mute that for testing purposes. Then you can say class profile factory is going to be factory.django. We're going to surplus the Django model factory. Oh. Then the profile has a user field, so we're going to get some fake. You can say this is factory. User is, remember there's a one-to-one relationship between a user and a profile. So that here will be represented as a sub-factory. So this is going to be sub-factory to tests.factories.user factory. We're going to create this factory shortly. Then phone number is going to be factory lazy attribute. Lazy attribute here, we're going to use a lambda function. So you can say lambda x. We're going to use faker.phone number, like that. Then for about me, the lazy attribute, we're going to use faker.sentence. We're going to generate a fake sentence. So faker.sentence, and that sentence should have like a number of words, let's say 5 words. So you can say NB words is equals to 5. So all this is in the Faker and Factory Boy documentation. So license, it's going to be a lazy attribute. So here for the license, you're going to say faker. It's just going to be text. And here we're going to say the maximum number of characters should be 6. Then for profile photo is going to be factory dot lazy attribute. We're going to use a lambda function. We're going to, for factory, for the profile photo, we're going to use a file extension. So you can say faker.file extension. So the extension here, the category is an image. Category there is image. Okay, next let's go to gender. So you can say gender is factory dot, it's a lazy attribute lambda x. Let's say here for gender, let's pass in the string. So you can say, you can use f strings and you say gender is other. Then we can say country. So for country is going to be factory dot lazy attribute lambda x. So you're going to use faker dot country code. So I hope you remember that all these fields are the fields that are in the profile model. So for city, we're going to say factory dot lazy attribute. We're going to use faker dot city. Is buyer is going to be false. Then is seller is going to be false. Then is agent is going to be false. Then top agent is going to be false. Then you can say rating is going to be factory dot lazy attribute. You can say lambda x is faker. Here we want to use some random integers. So you can say faker dot random underscore integer. Min is 1, max is 5 because our rating has to be from 1 to 5. Then number of reviews is going to be factory dot lazy attribute lambda x faker dot going to be a random integer again. This time minimum is 0 and the maximum is 25. Then now you can say class meta. Here you can say model is profile. Yep, and by now we should be used to this. I've definitely made a mistake, so let's go back here. Let me see. Let me just confirm everything. Profile photo. This is supposed to be categories, image. Then save that. Then let's go to the next section. Now we're going to declare the user factory. So you can say at factory.django that mute signals. We're going to mute the post save signal for this. Then you can say class is user factory. So it's factory factory.django model factory. That so for the user model you had a first name. So it's a lazy attribute. You're saying lambda x, you're doing faker dot first name. Then last name is the same, going to be last name. Last underscore name. Then we're going to do username and then email. So here we can say username is going to be for username, let's make it the same as first name. So you can just say first name. That doesn't really matter for this. Then email, we can say it's a lazy attribute. Let's pass in an email. So here we're going to pass in f strings. Then we're going to say, let's say alpha at realestate.com. Then we can say password is going to be factory.lazy attribute. So lambda x, we're going to say faker.password like that. Then is active is equals to true. Then is staff is equals to false. Then class meta, you can say model is going to be the auth. The auth user model. Then let's declare a class method. So this method is just going to control whether we create a normal user or we create a super user. So you can say at class method, then you can say define. We're going to overwrite the define underscore create method. So here we're going to pass in CLS for the class. model class, then any arguments and keyword arguments. Then we're going to say the manager, the default manager is going to be cls._get manager. We're going to pass in the model class. Then we're going to say if is super user in the keyword arguments. Here we're going to return manager dot create super user, passing in any args and keyword arguments. Else, if it's not, we're going just to create a normal user. We're going to return manager dot create user, passing in any args and keyword arguments. Then we can save this file. Then in the root directory, we shall create a conf_test.py file. This is where we shall define our fixtures. So fixtures are basically functions which will run before each test function to which is applied. So fixtures are also used to feed some data to the test, such as database connections, URL to test, and some sort of input data. So go back to the root directory here, create a new file yet again. This is going to be called conf_test.py. Then we're going to say import PyTest. Then from PyTest factory boy, we're going to import register. Then from tests.factories, we're going to import profile. It's a profile factory and a user factory. Let me see. Yes, user factory and profile factory. Good. Then we're going to register them. So you just say register the profile factory and register the user factory. Then we're going to create the fixture. You can use the say pytest.fixture. Then define a base user. So a base user, this will pass the parameters of database and the user underscore factory. So remember, once you register your factory like user factory, when you're using it in your fixtures, you make all the capital letters to be lowercase letters, and then you separate any two words with an underscore. So user factory becomes user underscore factory. Then you can say a new user is going to be user underscore factory dot create, like that. Then you're going to return a new user. Then we can say at pytest.fixture again. So define create a super user, pass in database and the user factory. Then you can say a new user is going to be user factory dot create, and this time is stuff is true and is super user is going to be true. Then you can return a new user. Then we're going to create another fixture. You're going to use that decorator. Then the next one is for profile. So define profile. It takes pin database, and this time, since it is profile factory there, this becomes profile underscore factory. Then you can say user profile is going to be profile factory dot create, like that. Then you can return the user profile. So save this file. Then in our tests users folder, we're going to create a test underscore models.py file. So go back to tests users here. Let's create a new file. We're going to call this test underscore models.py. And so here we want to run the test. So if you go back here, so you want to test the users model. So you can go to users models here. We see we have to run a test on line 32, line 36, 39. And if you go to the users, let's say managers, we have to run tests for all the lines that are indicated in red. Then for views, nothing. So let's start writing the tests. So in the model tests, users test, we're going to say import PyTest. Then first we're going to test the custom user model string representation. Remember here, users model, we want to test for this string representation, this one for the full name and that for the short name. So we can say define test underscore user underscore str. Remember, any test function has to start with the word test. Yeah. So we're going to pass in, So we're going to pass in the base user. Remember, base user is from conf test here. So we're going to pass in the base user. So here we're going to say test the custom user model string representation. Then we can say we're going to assert that the base user dot underscore string representation of this is equals to, this is double equals to f strings. What is it? The base user dot username, because if you come here, we say we are saying self dot username. So we're going to say that is the base user, base underscore user dot username. That's how we basically test for that. It's as simple as that. Then next, we're going to test the user short name. So remember here, we're saying the short name is also the same as self dot username. So you can say define test user short underscore name, takes in the base user. Here we're going to say test that the user models get underscore short name method works. Then here we can say the short name is going to be f strings. It's going to take in the base user dot username. Then we can say, we can assert that the base user, the base user dot get short underscore name method is equals to short name, like that. Then next we are going to, if you go back here, we want to test for the full name. So here we can say define test user underscore full underscore name, takes in the base user. We're going to say test that the user models get full name method works. Then you can say the full underscore name is going to be the base user. Come here, if we said it's the base user dot first name and the last name, then you can say here it's going to be f strings. So full name is going to be the base user. This is supposed to be first underscore name, then a space, then base user last name. Then we can assert that the base user dot get full name is equals to full name. Save that. Then the next test, we're going to test that the base user email is normalized. Remember here, if you come to the model managers, we normalize the email. So what we're going to do here, we're going to test for that. So you can say define test base user email is normalized. Normalized takes in the base user. So here we're going to say comment test that new user's email is normalized. Then here we can say, so an email can be let's say alpha at realestate.com. So we want to make sure that this is normalized, this part of the email is normalized. So you can assert that the base user dot email is going to be the same email but lowercase. But that's what normalization actually means. So next, we're also going to test the super user email is normalized. So define test super user email is normalized. So for this, we're going to take in super user. Then we're going to say test that an admin user's email is normalized. We can say email is just going to be the same, alpha at real estate. Copy this, put it there. Then we can say assert that the super user dot email is going to be email dot lower. Save that. Then we're going to test that the super user is not staff. So we can say here define test that the super user is staff. We're going to pass in the user. This time we're passing in the user factory, because remember it's in the user factory where we have If you go to factories, the user factory here, where we have like is active and is staff values. So we're passing in the user factory there. Then we can say here, test that an error is raised when an admin user has is staff. Let's say is staff set to false. Then we can say, so here we're going to say with PyTest.raise is going to raise a value error. So with PyTest raises value error as error like that. As error like that. We can say the user factory dot create. We can create a user using the factory. So now you see, now this is one of the importances of the factory. Rather than coming to define all these values again, we now use the factory by default, gives us all those fields. But here we can say is super user is equals to true, like that. And then set is staff is equals to false. So you're basically saying use this factory, user factory with these fields, and set is super user to true and is staff set to false. But in the factory is staff is set to false, is super user, is staff is set to false, is active set to true. So come back here and then we can do assert that the string of the error.value is going to be super users must have is underscore staff set to true. So where are we getting this string value of the error? If you go back to your model manager here, we had said this. If staff is not true, in line 53 and 54, we can raise super users must have is staff is equals to true. That is what we are testing here. Then you save that. Then next we are going to test that the super user is not super user. What do I mean? So you can say define test super user is not super user, like that. Here we're going to pass in the user factory. Then we can say test that an error is raised when an admin user has is super user set to false. So we can do the same. We can say with PyTest raises a value error as error. We can say user factory dot create. So pass in a super user. This time make it false. Then make is staff to be true. Then we can assert that the string of the value error is going to be super users must have is super user set to true. So if we confirm here, super users must have is super user set to true. Next, we can test that creating a user with no email raises an error. So you can say define test create user with no underscore email, pass in the user factory. Then you can see here test that creating a new user with no email address raises an error. Then you can say with PyTest it raises value error as that. I can say user factory.create, and this time we're going to pass email as none. Then you can assert that the str of error.value is going to be base user account, and email address is required. Let's just confirm that here. Base user account and email address is required. Then next we're going to test that creating a new user with no username raises an error. Define test create user with no username, takes in the user factory. So you can say here test that creating a new user with no username raises an error. So you can say here with PyTest So with PyTest.raises, the value error there as E, we can say user underscore factory.create. This time we're going to pass username as none. Then we can say assert that the string of error dot value is going to be, let's check here, users must submit a username. So users must submit a username. Then next we're going to define test create user with no past name. We'll be taking the user factory. So you can say test creating a new user without first name raises an error. Here you can say then with PyTest.raises value error as that. By now we should know what to do. The user factory.create. This time we're going to pass in first underscore name and make it none. Then we can assert that the string of error.value is going to be users must submit a first name. Then we're going to do one for last name. So we can just copy first name here, bring this here. So this is going to be last name. Test creating a new user without a last name raises an error. So here you can say user factory create. Now this is going to be last name is none. String values users must submit a last name. Save that. Then next we still have a lot to cover. So you can define test create super user with no email, text in the user factory. So here we're going to test that creating a super user without an email address raises an error. So then we can say with PyTest.raises value error as E, we can say user factory.create. So email is none here. Is super user is true. Is stuff is true. So we can assert that the string value of error.value is going to be admin account and email address is required. Then next, we're going to test that creating a super user without a password raises an error. So we can just copy this first one, the super user, paste it down and say test create super user with no, this time into email it's password like that. So test creating a super user without a password raises an error. So with PyTest.raises user factory.create, we don't need this. You can say is super user is true, is stuff is definitely true. Then we can say password is none, and we can say the error string is going to be here. Super users must have a password. Yep, I think that is it. What else? So let's see, we're going to test that a user puts in an incorrect email. So define test user test user email incorrect like that, takes in the user factory. Then we can say test that an error is raised when a non-valid email is provided. Then we can say with PyTest.raises value error as error, we can say user factory.create, and here we're going to say email can be realestate.com. So here you can say assert that the string value is going to be you must provide a valid email address. Yep, and that's all with regards to the tests that you can think of now based on the guidelines from coverage. But feel free to think of other other edge cases that we might not have thought about. So the next one we're going to do for the profile model, but the profile model we're not going to go extreme. This is already getting out of hand. So the profile model here, we're going to create a new file. Here we're going to say tests_models.py. Then we can say import PyTest. Then you can say define test profile string representation. Takes in the profile. Then you can say here test the profile model string representation. So here you can just say assert that the profile dot underscore string representation is going to be a strings. Here profile dot user dot usernames profile, like that. Then you save that. So what you can in your terminal, we can go back here and let's say make test. Hope this time we didn't make any errors. Aha. So what's causing this beautiful error is, so if you go to our users models, so let's go to models, where is application, go to models here. Remember here we're saying we want this first name to be title case and the last name to be title case, but this was a mistake because let me get rid of this here. Let me get rid of that there. This is because remember in our serializers we're already making sure here for the user serializer that we are going to get the first name as title case, then the last name as title case. So just correct this error there, remove the title method there, then go back. Let's hope this solves that out. Then let's run that again. Oh wow, we're still getting the error. So actually the mistake is on my end. I wasn't very keen. It's saying type error, the string object is not callable. So if you go back and yes, we've changed this here on the model because we are going to serialize and get it the first name and the last name as title case. That's still fine. So what you can do here is, the mistake is here. Where is it? Full name. This is not callable. There is where our error lies. So let's just go back here, clear the terminal, run make test again. Let's hope this time things work out. Yep, and you can see all 15 tests have passed and our total percentage has moved to 39%. So let's create the HTML version. You can say make test HTML. Good. So if you have your server still running that is serving the HTML version, if you go and reload, you'll see, just reload this, you'll see the report moves to 39%. And if you go to models, now all the lines are tested. Then go to managers, users managers, all the lines are tested. Then go to profiles, models, all the lines are tested. So there's still a lot more testing to be done in our apps. So feel free to continue writing even more tests for the models, views and serializers for the other application. But kindly note that coverage and its percentages just act as a very good starting point. So we can go back here and let's commit our code. Here we can say test, add custom user model and profile tests, make the commit, then feel free to push it to GitHub as usual. In our current setup, we have the Django backend server running on port 8000, whereas when we build our React client, that client would run on port 3000. In our Docker container, we want the backend and the frontend to communicate on a single port. We shall use NGINX as a reverse proxy and web server to solve that. Yeah! We shall also be using NGINX to serve our static and media files. The NGINX server will look at all the requests and figure out which backend or frontend service to route the requests to. For example, when a request comes into NGINX, it will look at the request path. If the route has /API/v1 etc., NGINX will direct that request to the Django API service. Else, if it's a request for /index.js or any other resource, the request will be redirected to the React client service. NGINX will basically watch incoming requests and route to appropriate services. So let's set up NGINX. So first bring down your containers. So in terminal you can run make down. Then, no resource found to remove because I'd already run this command before. Then let's go back to our IDE. In our Docker local directory, let's add an NGINX folder and then declare a Docker file and a default.conf file. So here, create a new folder. We're going to call this NGINX. Then create a new file. Here, we're going to call the file is going to be called, create a Docker file like that. Then create a new file. We're going to call this default.conf like that. Then in the Docker file, let's open the Docker file. Let's add some Docker instructions. So we're going to get the base image. So our base image here is going to be NGINX version 1.21.3 Alpine. Then we're going to use the run command. We're going to say run. We're going to remove the default.conf file and replace with the one that you're going to create shortly. So you can say run remove from /etc NGINX conf.d. We're going to remove defaults.conf. Then we're going to copy ours. So you can say copy./defaults.conf to /etc NGINX conf.d defaults.conf like that. Then in the default.conf file, we shall define upstreams and locations. So upstream basically defines a group of servers which can listen on different ports. The location block identifies the base paths or URLs which will get routed to our backend API. The client max body size sets the maximum allowed size of the client body request. This shall all make sense in a minute. So let's go to default.conf here. We can declare our upstream. So our upstream is going to be called API. Then we can say the server API is going to run on port 8000. Currently runs on port 8000. Then we can declare our server block. So here you can say the client maximum body size is going to be 20 megabytes. Whoa, 20 megabytes like that. So remember, this sets the maximum allowed size of the client request body. Then the server is going to listen on port 80. Then we're going to have a location block here. So location here, if you go to the home directory, which is /, what we're basically going to do here, we're going to do a proxy pass. So proxy pass this to HTTP /API. So if you go to the home directory here on /, pass this back to the upstream API service like that. Then we're going to set some headers. So you can say proxy _set_header. So here, what you're basically going to do is say x forwarded for, and we're going to pass that to the proxy add x forwarded _for like that. Then we're going to set some headers. You can say proxy _set_header. We can say host is going to be host. Then proxy redirect is going to be off. So these are just some of the basic configurations of NGINX. So you can read the documentation to get a deeper explanation of all this. Then we can say location. So I want to create another location that goes to our admin page. So our admin page is on super secret like that. So here again, when you go to super secret, I want to proxy pass this to, we want to pass this route to API. Then we're going to do the same thing, set the headers and redirect. Just copy all that, paste that in there, save that file. Then I want to declare another location block. So this is now for our static files. So we want to serve our static files with NGINX. So you can say location. If you go to / static files like that, / remember for these static files you have to add this trailing /. Here we're just going to do an alias. So the alias to this is going to be to /app, which is a working directory, and static files, like that. Then remember, when declaring this when declaring NGINX configurations, make sure you have this semicolon. I forgot one there, so make sure everything has a semicolon. Let's just confirm. Semicolon, good. Max body size, yes. Semicolons all over the place, good. Then the next one is going to be for any media files. So you can say location. If you go to /media, media files, what do you want to do? We want to make an alias to /app /media files, like that. Then you basically save this. So basically we're saying here our NGINX server is going to listen on port 8000, but our API upstream server listens on 8000. So we're going to proxy pass 8000 to port 80. Then if you go to the home directory, pass this back to the API upstream server, super secret the same. Then if you go to the location of static files, just serve the static files that are in the root directory. If you go to /media files, serve the media files that are in the root directory. This is all going to make sense once we implement this. So then in the Docker compose YML file here, we can now comment off in the API service here. We can now comment off this. Just comment that off, since we'll be using NGINX to serve our API. Then in this same Docker compose YML file, we are now going to add an NGINX service. So our compose file should have 3 services. That is the API, PostgreSDB, and now we're going to add NGINX. So let's add NGINX down here. Then we can say NGINX. So NGINX, this is our server. So for this one, it should always restart. So restart should be always. Then, so this depends on the API service. Remember, indentation has to be correct. Then for the volumes here, we want NGINX to help us serve our static and media files. So you can say static underscore volume. So remember, we've done these volumes here, static volume and media volume. So for the static volume, serve from /app /static files, like that. Then for media volume, serve from /app media files, like that. And so what this basically does is NGINX will look at this volume block here, then go back to the conf.file and see, to /static files, use this alias and serve that, media files, serve that. So now this is coming in full circle. Then for the build command, so build, we're going to now use the context. So we're going to declare the context here. The context is going to be ./docker local NGINX, like that. Then we're going to use the Docker file. So the Docker file we're going to use here is going to basically the Docker file. So basically look in this context where NGINX folder is here, then use this Docker file. That's what we mean. Then for the ports, so for the ports we're going to now say, you can create any port you want here. So me, I'm going to use 8080. So I'm going to map port 8080 to our server, which listens on port 80. Remember, here we had said that our server, NGINX server, is going to listen on port 80. So in the Docker compose file, you can assign this to anything. I can say to put here 1, 2, 3, 4 if I want. So you can just put 8080, map it to that. Then as usual, make the networks. So the networks here, we had said this is state react, like that. Then next, let's rebuild our containers. So you can go back to your terminal, clear this and say make build. Good, it seems our containers are up and running. So our application should now be running on port 8080 and not port 8000. So you can go back to your browser. If you go to localhost 8000, nothing should work. If you go to localhost 8080, yes, our application should work now. Then let's go to the admin, which is on /super secret. Good. As you can see, our admin page is now loaded. And this time, remember, it's working on port 8080. Then if at all you realize that your static files are not loading, or with your containers up and running, you can run the collect static command and NGINX will serve the static files based on our configuration. So remember, if at all it doesn't load, you can just say make collect static. But this command shouldn't be necessary because remember in our scripts we had said here, if I remember, in our start script we had said to also run collect static, so all should be okay. So our admin page should now load. So with our admin page, let's log into our super user account. So it was API-Imperfect. As you can see, everything is loading. So let's create up. So for the profiles here, let's just try and see if everything still works. So you can click on profiles. Then we have the super user profile here. Click on it. As you can see, everything loads on 80 now. Then let's make some edits. Let's say about me. Let's say I am the super user. Then the profile photo. Let's just pick a file, the default file here. Open that, then save. So you realize that now, since it's running from our containers on port 8080, it might be a little bit slow depending on your machine. Yeah, but that should be okay because it's now running multiple processes in the background. So everything seems to be working well. So let's commit our code. Come here. Let's say here we're going to say, is this a feature? Is this a chore? Let's say, okay, this is just a chore. Let's say set up NGINX and then serve static files like that. Save that. Then as usual, you're free to push this to your GitHub repo. Now it's time to configure Celery and Redis. Remember, in the previous section on user registration, password reset, and the use of the inquiries app, the sending of emails was done synchronously, and we had to wait for the email request to complete. This blocked the request response cycle up until the email was sent. We are now going to make our application more responsive and asynchronous by using Celery. Celery is an open source asynchronous task queue that's often used with Python-based web frameworks like Django to manage background work outside the typical request response cycle. In other words, rather than having to block a response that contains a long-running process, such as sending an email, you can run a HTTP response immediately and run the process as a background task. So Celery needs a message broker and a result backend. A message broker is an intermediary program used as a transport for producing or consuming tasks, whereas a result backend is used to store the result of a Celery task. For simplicity's sake, we shall use Redis as both our message broker and our result backend. So Redis is basically an in-memory data structure store or in-memory key value database and a message broker. So if your containers are running, bring them down with the, so you can say make down. Then we're going to add Redis, Celery, Flower, and Django Celery email to the requirements.txt file. So go to the requirements.txt file here. Here we're going to add Redis. So let's use Redis 3.5.3. Then we're going to use Celery version 4.4.7. Then we're going to use Flower version 0.9.7. Then you're going to use Django Celery email version 3.0.0. So for this one, maybe what you don't know here is Flower. So Flower is basically a real-time web application monitoring and administration tool for Celery. You'll see this shortly. Save that file. Then in the real estate folder, we're going to create a celery.py file where we shall configure Celery. So go to real estate here, create a new file here. We're going to call this celery.py like that. Then here we're going to configure Celery. You can say from __ future __ we're going to import absolute import like that. Then you can import the OS module. Then you can say from Celery import Celery like that. Then you can say from real _ estate, not .models. So we're going to do settings. We're going to import base. So here you can say os.environment. We're going to do some set defaults. We're going to say this Django settings module. We're going to say it's now going to be in real estate. Real _ estate .settings.development. Remember, this is the same config that is in the manage.py file here. This. So you're just basically pointing Celery to our settings. Since we're in development, it's settings.development. Then our Celery app, we can call it, this is going to be Celery. So our app here is going to be called real_estate. So here, feel free to change the name, whatever you want here for the Celery application. So I'll just call it the same as the project, which is real estate. Then we are going to read some config from Django settings. So we can say app.config from object. So real estate.settings.development here, and we're going to say, we're going to say the namespace here. The namespace is going to be in capital letters, Celery. So what basically this line does, it reads configuration from Django settings, and then the Celery namespace makes Celery config keys have the Celery prefix. Then the last one, you're going to load tasks in Django app. So you can say app.auto discover. So you want to auto discover, make this a lambda function here. Auto discover from base.installed apps. And then remember, this app here is our Celery app, which we had configured on this line. So here I just want to load any Django apps from the installed apps section. Save that file. Then in the same real estate folder, we're going to amend the init.py file. So init.py file here. So not the one in settings, so the one in just real estate, that one. So here we're going to say from __ future, we're going to import not print function, we're going to import absolute import and Unicode literals. Then you can say now from dot Celery, we're going to import app as the Celery app. Then you can say __ all is going to be Celery app, like that. Then make sure you add the trailing comma. Then you save that. So basically this line makes sure that the app is always imported when Django starts, such that the shared task will always use this app. So that's what we're basically doing here. Save that. Let me just confirm. Was it in real estate init.py? Good. Yeah. That is set. Then in our .env file, we're going to add environment variables for our broker and backend. And this time, since we said we're going to use Redis as both the broker and the backend, let's go to env here. And we say Celery _ broker is going to be Redis on port 6379/0. Then duplicate that. Now this is going to be Celery backend, like that. It's going to be the same. Save.env file. Then we're going to amend our env.example file to make sure that all environments we have so far in our project are added. So env.example. So what haven't we added? Let me see. We haven't added domain and Celery broker on the backend. So make sure you add that. Save.env.example. Then in the settings development.py file, we're going to amend the email backend config to point to Celery email backend. So here settings development.py file here. So the email backend here, let's change now this from SMTP email backend to the DJ Celery email, not mailer, email dot backends dot Celery. This is now going to be Celery email backend, like that. Then we're going to add some Celery config. Since Celery can read config from the Django settings file, we shall also add some Celery config for better management. So here, what we basically do at the bottom here, we can say now Celery broker _ URL is going to be from the environment variable Celery broker, like that. So now we can use this keyword Celery here, because remember in the init.py file here, note that in the Celery.py file here, we had said use and accept any namespaces from Celery. So now we're able to use the this as a namespace, Celery in capital letters. So next you can say Celery result backend So that is going to be Celery backend, not result backend, Celery backend. Then next one you can say Celery time zone if you want. So time zone for me, since I'm in Kigali, I'll say Africa, Kigali, like that. Save that file. Let me just check in our base.py file. What time zone did we set here? Let me see. Time zone Africa, Kigali. Okay, that's okay. Next, we're going to add Django Celery email to the third-party app section in the settings.base file. So here in the base.py file here, third-party apps, where are you? Here. We're going to add DJ Celery underscore email, like that. Save that file. Then we're going to do some Docker Compose config. So with the Django Celery configuration done, let's add the Redis and Celery services to the Docker Compose file. So make sure that the API service now depends also on Redis. It currently only depends on the Postgres DB. So let's close all these files here. Let's go to Docker Compose. Docker Compose here. And now let's search the API service. So API service, this time, it must also depend on, on Redis. We're going to create the service shortly. So let's put Redis in between Postgres and NGINX. So you can say Redis here. So Redis here is going to be, let's say the image. We're going to use Redis 5 Alpine, like that. Then we're going to say networks. So networks here is going to be our basic one, which is estate react. Good. Then so we're going to declare one for our Celery worker. So Celery worker, here we're going to build the context. Context is going to be the current directory. Then the Docker file we're going to use here is going to be ./docker local Django Docker file. Then the command we're going to use is start Celery worker. We'll declare this shortly. Start -Celery worker. Then as usual, volumes here, we're going to use app dot :/app, like that. Then our environment file here is going to be .env. Then this service depends on what does this depend on? It depends on Redis for the broker and message key. So Redis, and it also depends on the PostgreSDB database service. Then the networks as usual is estate react. Then that's it. So now we can declare the next service going to be for Flower. So remember, Flower is a real-time web application monitoring and administration tool for Celery. So you can say you're going to build this also. The context is the current directory. Not .local, it's just dot. Then the Docker file is going to be ./docker /local /Django /docker docker file, like that. Then the command we're going to use here, we're going to say it start Flower. Then the volumes we're going to use here, volumes are going to be one is up :/up. Then our environment file is going to be .env. Then the ports we want to run Flower on, we want to run Flower on port 555. So 5557, map it to 5555. Then we're going to say this depends on, so it depends on Redis, and it also depends on the Postgres DB service. Then the networks here is going to be estate react. So that is for Flower. So save this, and I think we are good. So next we're going to update the Docker file so that we can add the commands for start Celery and the Celery worker, these ones that we had said here. You have start Flower and start Celery. So go back to the Docker file here, Docker Django, the Docker file here. So just before entry point here, we're going to do the same thing like we did for this one. So let's just copy this. So this is going to be Docker local Django, now Celery worker, and we're going to start. So we're going to start from start Celery worker like that. So all this remains the same, but this goes to now to start Celery worker. Then this is going to start Celery worker. Remember, I'd explained what we're doing here before in the previous section. So let's copy, let's do one for flower. It's just going to be the same thing. But now we change these to flower here, flower and flower like that. Save your Docker file. Then we're now going to add the start scripts for flower and celery. Remember, we created this, we said run this start script. So let's create the scripts now. So we're going to create a Celery folder inside the Django directory at Docker local Django. Then further create the folders for the worker and flower within the Celery folder. So here within Django, here we're going to create a new folder. So here we're going to call the folder is Celery like that. Then we're going to create a new folder. Here it's for flower. Then the Celery folder, create a new folder again. This is going to be for worker. Then now for flower here, we can create a new file. This is going to be the start script. Then for the worker here, create a new file. This is going to be the start script like that. So folder structure, please be careful about the folder structure. If you're unsure, just check the project repo. Then we're going to update each of our 4 start script. So if you start with the Celery, so we're going to do for the Celery worker here, we're going to just as usual bin bash. Then we're going to set -o error exit again, set -o nonset. Then we're going to say Celery run the application is called real underscore estate. So let me just take you back. Remember here, where is it? Real estate Celery py. We had called our application here real estate, so that's what we are referencing here. So then say worker, run the Celery worker, and the log level for Celery worker should be info. Info like that. Save that. So for the start script for flower, here we're going to use the same logic we used for entry point to ensure that flower doesn't start up until the workers are ready. So let's just copy error exit and num like that here. Then we're going to say for worker ready. So remember, if you look at this entry point just here, remember here we did something for Postgres to make sure Postgres is ready. So we're going to use more or less the same logic for flower to ensure that the workers are ready. So here you can say for worker ready, Celery application, the Celery dash application you're talking about, dash application you're talking about is real estate, inspect, ping. We're going to ping it, then you can say until worker is ready, do. So here we're just going to not do sleep. Here we're going to say and 2. Here we're going to echo Celery workers are not available with a sad face if you want. Then we can say sleep 1, and that's basically done. Then done like that. Then we can have another echo statement here. Just copy that here. Else you can say Celery workers are available and ready. Then we can have smiley face if you wish, like that. Then we can say for flower. Now for flower, we can say for flower we can say up is the real estate here, and then the broker is going to be get from our environment variables using the $, double quotations, $, here, it's the Celery broker, like that. Then save that file. So for these start scripts, make sure you have the syntax and the spaces right as we have typed. If in doubt, refer to the project repo on GitHub. So next we're going to sort out the worker auto reloading. So while Django provides auto reloading out of the box, Celery does not. So we have to manually restart the workers every time we make code changes to a task, which can be very hectic in development. We shall solve the Celery worker auto reloading problem using Watchdog, so that when changes are made to the code base, our Celery workers are restarted. So first, bring down your containers. Let's say make down. So we get an error. So line 44, mapping values are not allowed in this context. So let's go to our Docker Compose YAML file here, where we're doing our Celery worker. So is there an indentation problem here? Image Celery worker build with the context of here we missed the full colon. So save that. Then let's try this again. Let's bring down containers, make down. Good. So no resource found to remove because we'd already run the make down command before. So I think we are in a better place now. So here we're going to now add some requirements to our txt file. Let's add some more requirements. So we're going to add our GH 0.26.2. Then we're going to add Python YAML. These are dependencies to make Watchdog work for us. 5.3.1. Then we're going to now run Watchdog is 1.0.2. So remember, Watchdog helps us to make Celery workers auto reload. Then we're going to update our Docker local Django Celery worker start script. So go back to Docker local Django Celery worker the start script. So now we're going to amend this line here. We're going to say now this is going to be watch me do auto restart -d real estate, then -p look at all the py files, star.py, then do Celery worker, the Celery worker. Now we can bring all this. Celery worker -a is real estate, and we can say log level as usual is info, like that. Save the file. Lastly, we need to rearrange our Django apps in the settings based py file to make sure that the Django contrib conti types is the first input. So go back to first save this file, then let's go to our settings. Where are you? Settings here, base. Then for our Django applications here, let's make contrib types the first input, then the rest can follow. Save the file, then let's build our containers. So just run make build. So with our containers built, for good measure, let's just check if our logs are also correct. So you can say make show logs. We made an error. So Celery object has no attribute auto discover. There always has to be a problem somewhere. So here we're told attribute error, Celery object has no attribute auto discover. Yes. So if you go back to celery.py, it is in real estate here. Celery.py here, we can see this is wrong. So that is supposed to be auto app.autodiscover underscore tasks, like that. Then save this, run make down, then run make build again, then run make show logs, and I think we are good. So with the containers up and running, please note that now our server this time will be running on port 8080. First, confirm that Flower is running in the browser by navigating to localhost 5557. So go back to localhost here. Let's say localhost 5557. Nice. As you can see, Flower is now active and running. So through this dashboard, we shall be able to see any asynchronous tasks and others and their successes or failure status. So remember, one of the routes that required email sending was the one for inquiries. So we can test that out. So we can go to localhost 8080. So in Insomnia now, or if you're using Postman, go to inquiries. To send an inquiry here now, I'm going to change my environment variable to be Docker. So Docker just makes now its localhost 8080. Done. So let's send an inquiry this time round. Click on send, then come to Flower. We're going to see our task added. You see, it's active task here is 1, that is sending of the email. It has been started. Then give it a while. Then if you go back to the dashboard here again, once it succeeds, we'll have here succeeded or failed. So processed is 1 here. Succeeded has now changed to 1. So if you look at now the sending of the email, it was successful. So that basically works. So Flower just helps you monitor that. So let's send this again. So if you send, let's say this is test 2, send. As you can see now, the request was done like ASAP. There was no waiting. And you can see again active. There's one active request here. Look at it. It has been started. Go back to the dashboard. And it succeeded. Now you can see succeeded here is 2. So both of the requests are successful. And if you go to mail trap, we're going to see the 2 emails sent. So as you can see now, any request that requires an email on the API client here, there will be no waiting as there was waiting before. It will just be done like immediately. So now if you go to Mailtrap, you'll be able to see that the emails have been sent. You see messages sent, messages sent. So if we're to register a user, again, let's go to users. That one required an email. So register new user here. Let's say Merideka. Send. Oh no, it changed the URL. This is supposed to be now Docker. I forgot. Sorry. So this is not token. This is Docker URL. Docker URL is localhost 8080. Done. If you click send, the request was done immediately. Go to Flower. We're going to go to the dashboard. We're going to see there's one active request here, and that active request is for registering a user. Then when it succeeded, you go to the succeeded tab here. There are now 3 successful processes. Then you go to Mailtrap. You can see the email was sent. So this time now things are, our application is more responsive. There's no waiting around for the request response cycle. So let's just go ahead and activate this user here. As usual, you copy this. It's 4.4 because we don't have the front end built. But then again, it's not supposed to be localhost 8000. So let's go back to our environment file here. So domain now is going to be localhost 8080. Save that. Then let's see if it just works without doing anything else. So let's go back to Insomnia here. Activate our new user. So the URL here is going to be the Docker URL. Done. Then the token, let's say just copy that token from the URL here. Token is going to be that. Send, no response, but we should get an email. Or let's look on Flower on the dashboard. Yes, there's one active request. Then it has succeeded. Good. So the active request was the one for like getting the activation email. This one. And you can see you're now activated too and ready to use the site. Good. So at this point, feel free to redo all the API endpoints so that you can populate the Postgres database with some data. Just note that the endpoint is now localhost 8080. But before we do the React section, I'm going to do a very quick video on the use of Insomnia and how to use these environment variables, because one of you had asked about this. Then we'll also populate our database with some data. So before we end, as usual, let's go back to our client here. Let's commit our code. So you can say this is a feature. Here add Celery and Flower. Make the commit. Then as usual, push this to our repo. So thanks so much for watching. Hope you got some value from this. Cheers and see you in the next section.